Let's understand the global value chain. Whatever the chips we design, whatever the chips we create, basically we use them to create various electronic products. If you consider the electronic products, the electronic systems market is more than 1,800 billion worth. And you consider semiconductors, the market value is more than 500 billion. And the foundry alone, we were discussing about fabrication, whatever that's happening in Taiwan or China. The foundry alone produces more than 100 billion business. And the embedded system market value is more than 10 billion. And the EDA market is again more than 10 billion. You consider the global semiconductor industry, it's going to grow as a $1 trillion industry by 2030. You consider 2023, the revenue was more than 500 billion. You consider 500 billion, the revenue has come from various sources like logic chips, that was the primary source, and memory chips, the second one, more than 90 billion, and microcontrollers. And the other source is automotive chips. And 2024 revenue, estimated market valuation would be more than 600 billion. Again, logic chips and memory chips, they would be the primary revenue source. And 70% growth from three industries: automotive, high-performance computing, networking, and data storage, and IoT and wireless. Let me explain the semiconductor ecosystem. As part of the design ecosystem, we have various companies. We classify them as fabless IP companies, EDA companies, and design services companies. Let's look at chip makers. We call them as IDMs. The difference is IDMs, integrated device manufacturers, companies like Intel, Samsung, they are all IDMs, integrated device manufacturers. They sell silicon. What it means is they have their own foundry, they do the design, they fabricate the design, and they sell the actual silicon. But you consider chip maker, they could be fabless chip maker. Companies like NVIDIA, AMD, they make the chip, but they don't fabricate the chip. That's the main difference. Now, the chip makers, whether they are fabless chip maker or IDM, they need three things mainly. One is IP, intellectual property. That's nothing but hardware component. To design any chip, you need basic building blocks. They are all like hardware components. Hardware components could be processors, memories, memory controllers, interface components like USB, PCIe, DDR, and system controllers. That involves PLL, clock generators, reset control, and you need various interfaces like GPIO, SPI, UART, and you might need interfaces like AMBA, advanced microcontroller bus architecture. There could be other on-chip buses also. So chip makers need hundreds of IPs, thousands of IPs for their chips. Basically, whatever they create, mostly they would be like SoC, system on a chip. So they need IPs, hardware components. Fabless IP companies, companies like Arm, Rambus, Sci-Fi, they sell hardware components, IPs, intellectual properties. The other thing what they need, chip makers need EDA tools, electronic design, automation. Companies like Synopsys, Siemens, Cadence, they provide all the necessary tools for the chip design. You consider the design flow. We follow various steps. We follow front-end design flow. We follow physical design flow. As part of front-end, there are various things. And as part of physical design, we follow various steps. For every step, we might need EDA tool. So the entire design flow is completely automated. Without EDA tool, we can't design the chip. So they provide hundreds of tools, various kinds of EDA tools. The other thing, chip makers need brilliant engineers like you. There are design services companies. They provide engineers like you as consultants, companies like Capgemini, Accenture, TCS, Wipro. They are very popular for design services. Now let's look at chip makers. As I mentioned, we can classify them as fabless chip maker or integrated device manufacturer. You need to understand the difference. Companies like Intel, Samsung, they have their own foundry. They do everything. They own the design. They take the design through complete design flow. And then the routed netlist, they manufacture with the help of their own foundry. They have their own foundry. So what they sell is the silicon. They don't sell the IP. But you consider the companies like NVIDIA, AMD, they also sell the silicon, but they don't have the foundry. So we call them as fabless chip maker. So what they do is, they own the design, they take the design through complete design flow, and then whatever the netlist they generate, GDS2, they will outsource the fabrication work to companies like TSMC, Taiwan Semiconductor Manufacturing Company, that's based out of Taiwan. They send the netlist to TSMC, and TSMC is their foundry, their partner. So they outsource the chip manufacturing to external vendor. That's why we call them as fabless chip maker. But still what they sell? Silicon. We can buy x86 processor from AMD or GPUs from NVIDIA. That's the main difference between fabless chip maker and integrated device manufacturer. We can classify the chip makers as companies specialized in processor. Companies like Intel, NVIDIA, AMD, they are specialized in processor. Companies specialized in wireless, Qualcomm, Broadcom, they are specialized in wireless. Companies like NXP, ST Micro, Infineon, Analog Devices, Continental, they are specialized in automotive. They make chips, could be embedded microcontrollers for automotive industry. And OEMs like Apple, Samsung, or Google, they are very popular for consumer. And companies like Micron, SanDisk, they are very popular for memories. And companies like Amazon, Microsoft, they are specialized in cloud. So there could be various kinds of chip makers or IDMs. And what we do at Maven Silicon, basically we train engineers like you. If you want to deal with anything as part of the design ecosystem, you want to work with some IP company or EDA company or design services company, or you want to work with any chip maker, we are there to help you. We can train engineers on anything as part of the design flow. So we have various courses for engineers like you. If you want to become a designer, we can train you on RTL design. If you want to become a verification engineer, we can train you on design verification. So there could be various domains in chip design. You can become a design engineer. You can become a verification engineer to verify the chip. You can also deal with testing. It's called design for testing. You can also deal with physical design. So there are many things you might want to learn. Static timing analysis or clock tree synthesis or physical verification, layout versus schematic. So we train engineers on various things as part of the design flow. So we deal with both front-end and physical design. All right. Now let's look at the manufacturing ecosystem. Generally, engineers like us, we don't deal much with manufacturing. Of course, they need engineers like us, but that's very minimal. So whatever we do, that's pretty much related to chip design. So we are going to be part of the design ecosystem, right? If you are interested in VLSI, very large scale integration, then you can deal with any of these companies. Fabless IP companies, EDA, design services, or any of the chip makers, all these companies. If you are interested in chip manufacturing, then you might want to look at the manufacturing specific subjects, domains. Right. Now, let's understand the manufacturing ecosystem. Basically, there are foundries like TSMC, Global Foundries, UMC, Samsung has its own foundry, Intel has its own foundry. All these foundries fabricate the chip. And the fabrication happens pretty much in Taiwan. To fabricate the chip, they need two things mainly. One is specialized materials that includes wafers, gases, chemicals. It's a complex process. It involves various kinds of materials. So they need specialized materials. They also need equipment. Companies like ASML, they are very popular for photolithography. So all these companies provide materials and equipment to the foundries, and then they assemble all the equipment and they make the supply chain within their factory. That's how they build the foundry. So that's related to chip manufacturing. So overall, to summarize, chip makers could be fabless chip makers or integrated device manufacturer. The difference is fabless chip makers outsource their chip fabrication to external companies like TSMC, and IDMs, integrated device manufacturers, companies like Intel, Samsung, they have their own foundry. That's the only difference. Whether they are fabless chip makers or IDMs, basically they make the chip. They sell the silicon, no doubt. Mostly whatever they make, it would be like system on a chip. Now to realize this kind of complex system on a chip, they need hundreds of IPs. So there are companies like fabless IP companies. They provide all kinds of IPs. They also need EDA tools. So we use hundreds of tools as part of the design flow. We deal with various things as part of the design flow. And there are companies like Synopsys, Cadence, Siemens. They are specialized in providing EDA. The most important thing is not only EDA tools, they also provide IPs. For example, if you want to work as part of the EDA industry, you can also deal with IP design. You don't have to deal with only EDA. That's again another thing. Also, chip makers need brilliant engineers like you. They need army of engineers. And that's what services companies do. Companies like Capgemini, Accenture, Wipro, they provide engineers as consultants for the chip makers. All right.